So another family of organic compounds like alcohols or like alkenes, like alkanes or like esters is carboxylic acids. Their acids mean just like mineral acids, but we call them carboxylic acid because their functional group, the reactive part of an organic molecule, distinctive part that differentiates it from the other, and that is basically this carboxyl functional group. It is written like CO double bond and OH. Okay, this is the carboxyl functional group that give this organic acid the properties of acids, because this hydrogen which is attached with oxygen is ionizable. Okay, it is polar, and in water it breaks up, just like H2SO4 has these two hydrogen as ionizable hydrogen. Okay, so carboxyl functional group CO2H, they may have a long carbon chain, like in fatty acids there is a long carbon chain present, but end of the carbon chain there is a carboxyl functional group present, and that's why they are called as carboxylic acid. Natural occurring acids, citrus fruit, lot of sour thing it is, citric acid, carboxylic acid it is, malic acid, apples, lactic acid, milk, and tartaric acid in grapes, and plenty of fatty acids we have. When we sweat, basically fatty acids are coming out, and dogs can differentiate the differences between the fatty acids. That is why somehow they can trace a person after robbery. Carboxylic acids are naturally occurring acids, and they have carboxyl functional group. Okay, general formula CnH2n plus 1 carboxyl has a functional group, N may be 0, 1, 2, 3, N may be 0 methanoic acid. Or another easy to apply is CnH2nO2, mean N basically stand for number of carbon atom. You want to produce the first member of the carboxylic acid family, that should be one carbon containing thing, methanoic acid, or this thing. And since it has one carbon, as a rule it is meth, but not methane, not methane, methanol, rather it is methanoic acid. Oic goes for carboxylic. And if it is two carbon thing, always start numbering from the carbon atom that is directly attached to the functional group. So this is carbon 1, this is carbon 2. Count this as 1, this is 2, this is important, remember this is 1, ethanoic acid. Had it been a 3 carbon thing, it should have been propanoic acid. A 4 carbon thing, a butanoic acid. 5 carbon thing, pentanoic. So simpler acids contain only one carboxyl as a functional group, but there may be multiple functional group present in an organic molecule. It may even contain 2 carboxyl functional group, some of the organic acids. Okay, so methanoic, ethanoic, propanoic, butanoic, pentanoic, all are these carboxylic acids, and they change from one another by presence of one extra carbon atom and 2 hydrogens. So that also makes a carboxylic acid homologous series, methanoic, 2 carbon atom, you call it as ethanoic, and so on, propanoic, butanoic, pentanoic. As the carbon chain increase, of course there are certain properties like carboxylic acids, melting point and boiling point and densities and other variations are seen, like in a carboxyl homologous series, carboxylic acid homologous series. I said they are naturally occurring as well, but so many of them are synthesized in the industry as well. Like most common carboxylic acid, the well-known premier member of the series has huge uses, and that is ethanoic acid. Other name for ethanoic acid normally is acetic acid or vinegar, because ethanoic acid, acetic acid or vinegar is largely used as a food preservative. Like you might have seen in supermarkets, many things like olives in the ethanoic acid, preserved in ethanoic acid, stay for longer. Acids prevent the basically growth of bacteria like HCl in our stomach. Okay, so they are used as food flavoring agents, acetic acid, meat tenderizer, softening agent, plenty of uses there. Carboxylic acid, remember, citric acid we eat, like in citrus fruit, malic acid in apples, lactic acid, milk, and tartaric acid. Why they are not actually harming us? Because they are very weak acid, extremely weak acid, very poor ionization. If there are 1000 particles of ethanoic acid, 96 may stay unionized. Only 4 may ionize. So very poor ionization, that makes them partially ionizable. They are partially ionizable. Look at the two-way arrow. That is why they are very weak acids. However, if you compare them with the mineral acids, you will find mineral acids are very strong because they completely ionize. They release plenty of hydrogen ions. Almost all the hydrogen ions sulfuric acid releases. That is why they are very strong, because strength of acid depends on how much hydrogen ions are ionized, given into the water, and that actually decides the pH. Concentration of hydrogen ion high, pH low, stronger acid. But these acids have a higher pH, normally 5, 6, because their hydrogen ion concentration is very less. Partially ionized, whether it is methanoic or ethanoic or propanoic. Methanoic acid, very common acid. Methanoic acid, formic acid, bee sting contain this. That's why pinches a lot if it bites. So carboxylic acid, I said, are like mineral acid. Their reactions are same, but they are slow. They will be slow in the reaction. You put a metal into the carboxylic acid, ethanoic acid, suppose, hydrogen gas is produced. But you will see the observation what? You will mention the observation. Less bubbles, less vigorous reaction, slow reaction. Okay, not that much of phase, not that much of effervescence. But if you add a metal into sulfuric acid, then plenty of phase and effervescence, a lot of vigorous reaction, and quick evolution of the hydrogen gas will be seen. You can compare in some experiment, quick evolution of hydrogen gas produced, there the less evolution of the hydrogen gas, slow reaction. If concentration and other factors are same, amount of the hydrogen produced may be same in both cases. But in case of carboxylic acid, it is slow. In case of mineral acid, reaction finishes so earlier, quick evolution of hydrogen gas. So the difference is basically the ionization and extent of ionization. Adding a metal may completely ionize organic acid, but reaction will still stay what? Slow, because metal will constantly displace the hydrogen ion out of the equation. As a result, this reversible reaction will move forward, and complete ionization is end of the day, but there it is prompt and so quick. Carboxylic acid, sometimes you need to know the reactions, and I said their reactions are just like the mineral acids. Okay, but slow they are. Like metal and acid produce what? Salt and hydrogen. Look at the metal, sodium, methanoic acid, sodium, ethonate, metal, sodium, ethanoic acid. This is sodium ethonate. This part 2 carbon atoms. Okay, and this is metal salt, sodium ethonate. Or it is magnesium and acetic acid, magnesium acetate or magnesium ethonate. Balancing is different, you need to know, because here magnesium has a 2 plus ions, magnesium's valency is 2 plus, sodium valency is 1 plus. That is why it is sodium ethonate like this, but magnesium ethonate is like this. And then it is magnesium oxide and acid, magnesium ethonate and water. Remember always, the formula of a salt depend only on the metal attached. Otherwise carboxylate ion will be always 1 minus. But if metal ion is 2 plus, then it means there should be 2 staying around. If it's 3 plus like aluminum, there should be 3 around the bracket. So practice these equations. Similar equation as mineral acid, but formulas are changed. Magnesium oxide and acid will produce what? Magnesium ethonate and water. Metal oxide and acid, as usual, salt and water. Metal and acid, salt and hydrogen. Metal carbonate and acid, salt, water, but fizz and effervescence, showing that carbonate group is present, carbon dioxide. Plenty of fizz. If it is metal hydroxide and acid, obviously neutralization, again salt and water. So do practice these equations. They are often the part of the exam because of the balancing thing. The student make mistakes in deciding the valency. Look at the group of the metal involved and the valency it should carry and the final formula that is yielded, and practice these balancing stuff. That's why examiner gave it into. And one important property of carboxylic acid, they react with alcohol and produce esters. That topic has already been discussed in a full video. Okay, that is basically the carboxylic acids, the organic acid, the CO2H containing organic molecules, general formulas. Naturally occurring, they are too much, but artificially they are synthesized a lot, like ethanoic acid because of huge uses, and their ionization differences completely ionize that mineral acid, weakly ionized, and carboxylic acid do react just like mineral acids, but reactions are slow and their observation is definitely slow. Like case of magnesium carbonate and HCl, it will fizz and effervescence and plenty of evolution of carbon dioxide. But in case of metal carbonate and ethanoic acid, there will be less evolution. Quick, it is not, it is slow. So differentiate, you can differentiate things, okay? That is the carboxylic acids.